In this video, we're going to take a look at the RBF Nodes add-on for Blender. RBF stands for Radial Basis Function and is used to approximate or interpolate a given set of values at any defined sample point. RBFs have a wide range of applications and can be very helpful when regular ways of driving values fail in 3D animation. It basically allows us to interpolate multiple values based on a set of sample values or poses, which are defined by the artist in advance. For standard drivers, such multi-value interpolation is not easily or even impossible to achieve. Like a driver in Blender can have multiple input values, but only one output target. RBFs can solve multiple output values based on multiple input values. Of course, there's a lot more to RBFs in general, but since this is about how to get started with the RBF nodes in Blender, I'm going to skip further details so you can see how it works. RBF Nodes has its own node tree to make it independent from any modes and panels. Even though RBFs are commonly used for rigging to drive certain deformation effects, it would be a waste to limit it to armatures only. Therefore, you can use it with objects, armatures, shaders and geometry nodes, which makes it very versatile. In the RBF Nodes editor, it's important to open the side panel, which houses the few but important buttons. First, I need to create a new RBF setup by pressing the according button. Of course, I can create the necessary nodes manually, but this gives us a basic starting point. The RBF node tree is set to fake user by default, so nothing gets lost. Just because until the RBF is activated, the nodes aren't tied to anything and are just sitting in the scene. The setup consists of 4 basic elements, of which 3 are currently visible. The central RBF node is the core element, which handles all the inputs and outputs and does the interpolation. To the left are the input objects. We can have as many objects as we want with as many properties as we need. Currently, no properties are defined. This input section defines the values which act as the driver for the interpolation. To the right are the output objects, which define the properties being driven. The 4th element are the poses, which are missing because we don't have any properties to begin with. Let's start with a simple example. The position of the robot should drive its orientation, the rotation of its legs, and the color of its eyes. This means 2 positional values, we're going to skip the height, drive a rotation value, a custom property, and a RGB shader value. I have a temporary animation on the position to make it easier to set up poses. To define which properties act as the driver for the setup, I pick the animated controller of the robot on the Object Input node. Then I add a new Input node, either through the menu or by pressing Shift-A. Since we need the position of the robot, I choose Location. As you can see, there are other options as well, of which most should be obvious. I connect the location output with the properties input of the object node and activate X and Z for the axes. In my case, Y is up, which is needed. We can connect as many property nodes to the object's properties input node as we need. That's about it for the driving side of things. Now we want to set up what's being driven. First, the orientation of the robot, which is the rotation around the Y-axis of the controller. So again, I define the controller as the object and add an output node of type rotation. Since it's a single axis rotation, Euler will do just fine and the axis is Y. Next, the legs should rotate. This is controlled by a custom property on the main controller object. For this, I create a new output node of type custom, not to be confused with property, which is used to access default Blender object properties. If you have custom properties, you need to use a custom node. I connect the custom node with the object node, and this gives me access to the list of custom properties of this node. Again, it's possible to connect as many nodes to the particular output as necessary. Lastly, I want to drive the color of the robot's eyes. For this, I need to link the responsible shading node. I open my shader editor and focus on the material node which should be used. In my case, it's a RGB mix node set to multiply. I select the node and press the button Link Output Node, since the node should be driven by the RBF. If it should act as a driver, it has to be linked as an input node. With the node added to the tree, we can see that it's already set to material. The node's parent is the eyes material, and the node's name is Mix. I only need to select the property, which is Color 2. And this is about everything we need for the general definition of the RBF, which input values drive which output values. To tell the RBF the value range within the interpolation should occur, it's necessary to define a basic set of poses or sample points. Basically, these are the extremes of the range of driving values. In theory, 2 poses are needed in order for the RBF to work, but this would also be pointless since such an interpolation can easily be created in some other way. In my case, I want to interpolate between 5 different poses. The first pose is generally the rest pose, which is defined by the default values. To capture the current set of values, which is a combination of driving and driven values, I press the Add Pose button in the side panel. This adds a new node to the setup and gets connected to the poses input of the RBF node. The second pose will be the first offset position of the robot, in my case easily acquired by the predefined animation. The robot gets rotated, the leg's rotation property gets a new value, and so does the color property of the mix node. Pressing the Add Pose button captures the state as a new pose. To get back to a certain pose, I can press the Recall button on the pose node. And to edit the pose values, I can press the Edit button, adjust the value, and then press Edit again to store the change. The same applies to the remaining poses. With all the nodes in place, it's time to activate the RBF. This is simply done by pressing the Activate RBF button. If the node has been successfully activated, it will display with a green background color. Activation performs the necessary internal computations, which is the core of the RBF. The result is then used to calculate the interpolation of the driven values based on the driving input. Since most of the calculations are performed in advance, the actual work the RBF has to do per frame or per scene change can be kept at a minimum and therefore helps performance. In case of an error, the node displays in red. Usually, the cause for errors are faulty poses, like when 1 or more poses have a different number of values, maybe you added or removed properties while setting up poses, or 2 poses contain the same set of values. The successful calculation of the RBF very much depends on the input and output values. When activated, the properties of the output nodes drive the actual target properties by simple driver expressions. To remove the driving relationships, press the Reset RBF button in the side panel. The resulting interpolation of the RBF depends on the defined poses and 2 attributes which are available on the RBF node. Kernel sets the basic fall-off curve, which is used to blend between the values, and radius sets the general width of the interpolation range. Without wanting to go into further detail at this point, setting these 2 attributes always depends on the current setup and usage. It's usually best to try different settings and then decide which produces the best results. And this wraps up the basics for the RBF nodes. 2 last important things to mention. First, in order to playback or render a scene containing RBF nodes, it's mandatory that the add-on is installed. Since Blender doesn't offer any outside access to the dependency graph in its current state, the evaluation of the RBF nodes needs to get triggered through the add-on. If the add-on is not available, the nodes don't know when to evaluate. Second, even though the virtual number of input and output values is unlimited, there's an internal limit due to technical limitations of Blender. Currently, a pose can store 1024 values, which are shared amongst driver and driven values. If this value is not sufficient, it can be easily expanded on demand by your local coding mate.